How to handle floating point precision in Arduino programming. Imagine you're building a robot that needs to measure tiny changes in temperature or voltage. If your calculations are off by even a small amount, your project might not work as expected. That's where understanding floating point precision becomes important. When you program an Arduino, you often use floating point numbers to handle real-world data. But these numbers have limitations. They are stored in a format called IEEE 754, which uses for bytes or 32 bits. This gives you about 6 to 7 digits of precision. So, if you try to work with very small differences or requiring more digits, you might run into errors. The Arduino double type is usually the same as flow on most boards, so it doesn't give you extra precision. This is because of the hardware design and the way the compiler handles these data types. When you do calculations involving very small numbers or subtract nearly equal values, rounding errors can happen. These small errors can add up and cause your results to be inaccurate. To handle this, you can try to minimize floating point use. Instead, switch to integer or fixed point math. For example, instead of working with decimal numbers directly, multiply all values by a factor like 100 or 1000. Do your calculations with integers, then convert back to float only when you need to display or send data. Limiting the number of decimal places you work with also helps. If you only need 2 decimal places, multiply your float by 100, cast it to an integer, then divide by 100. This reduces noise and prevents tiny errors from affecting your results. Be careful when subtracting to close floating point numbers. This can cause a big relative error. If your algorithm involves this, try to change the approach or use higher precision hardware if possible. External libraries can sometimes help emulate higher precision, but they are slow and use more memory, which isn't ideal for Arduino's limited resources. Remember that floating point numbers can't exactly representing some decimal fractions like 0.1. This causes small inaccuracies that can accumulate. Knowing this helps you design algorithms that are tolerant of such errors. For many sensor readings or control signals, float is enough if you limit your decimal places. For example, if you're controlling a servo motor, reading a float value and mapping it to pulse widths works well if you keep the precision in check. Always test your code thoroughly to see how rounding errors might affect your project. In summary, understanding the limits of float and double types on Arduino helps you write more accurate and reliable code. Use integer math when possible, limit decimal places, and design your algorithms to be tolerant of small errors. If you need higher precision, consider using more capable microcontrollers or external processing units.